Howdy, howdy. Is everyone nice and refreshed and awake? I love it, I love it. Okay, I won't say anything about me though. So, who here is excited about animation? Okay, I'm actually curious here. How many of you use CSS animations? Oh yeah, my kind of people. How many people here use like a animation library like GreenSock? It's less people. Okay, well, you know, it's CSS Day, so I assumed we were all going to be down with the CSS. I'm assuming this is an audience of awesome front-end developers. Sweet, good. Any designers in the house? Oh, okay, good. All right, moving on. Enough about you, now about me. You might remember me from such web animation collaborations as DevTools Challenger that I put together with the awesome people at Mozilla. Thanks, Mozilla, for sponsoring this wonderful conference. This little project here helped show off, what was it? Firefox Developer Edition's awesome animation tools, still my favorite animation tools in a browser. I've also helped clients build motion design into their user interface and design systems at scale. And now I'm a program manager over at Microsoft, where I work on everybody's favorite browser, Edge. Yeah! Love my team. But before all this, I used to be a professional cartoonist making webcomics for teenage girls for a living. True story. There's not a lot of money in that, though, so I ended up getting into a different career, one that could pay for health insurance. You know, in the United States, we have a messed up healthcare system. So I got a real job, and I turned my back on creating stories. I thought I would never tell stories again, and that would be the end of my artistic career. I'm curious, how many people here know who Scott McCloud is, author of Understanding Comics? So for everyone who did not put their paws in the air, I've got some homework for you. You're going to go home and you're going to read Understanding Comics. It's a great book. It's a great introduction to story, narrative flow, and design from the wonderful perspective of comics, and it is a gigantic comic book. But this is the author, and in his second book, Reinventing Comics, which was equally as large, it was all about Scott putting out this idea that the internet was going to change how people told stories, that we were all going to be telling these great expansive universe comics on something he called the infinite canvas. Now, a lot of the ideas in this book were way ahead of their time. Like, he really believed micropayments was going to change the world, and micropayments are something we're only just starting to talk about again. So he was talking about, you know, there's going to be audio and speech recognition and stories that listen to you and react with you. And so I'm working my day job in front-end development, and I started seeing all these great APIs coming out. I started seeing web audio and speech recognition. I saw CSS Animations and Transitions. I was like, oh my God, the prophecies are true. I can tell stories on this infinite canvas. Yes. I was very excited. So I decided to do a project with Adobe Inspire called Alice in Videoland. And I don't mean the Swedish Electro Clash band, although I am a fan. I was talking about this Alice in Videoland. This was a little demo project done right between when Flash was dead and when people understood how CSS animations worked. And at the time that this was published, designers looked at this and were like, how did you do that? This is on an iPad. How did you do this? It was all done with CSS Animations and Transitions. And I still get emails today from designers who, reading Adobe Inspire, this was their introduction to CSS. So pretty cool. So that was a video. That was a video of interacting with this little scrolling thing. There was maybe one point where you click on something and something happens. It wasn't very interactive. That's a problem with CSS animations. I could have just filmed that in After Effects and put that up here. It didn't have to be done with HTML or CSS. CSS animations are very declarative. They're not very interactive. Interactive animation needs extra libraries like GreenSock or Snap SVG or Mo.js or other libraries that do not have logos, or they'd be up here. Word to the wise, if you have a library, invest in a logo so you can be on people's slides. I'm not putting your GitHub page up here. So it's still tough. Browsers weren't designed for animations other than scrolling. They were designed to be document displayers. We've been missing out since the death of Flash. The internet has not been a very animated place, but that's been changing. So let's have a little history lesson here. Before CSS Animations or Transitions, over a decade ago, we had something called the Synchronized Multimedia Integration Language. It was, we know it as SMILE. And this is used to animate SVGs. This was back in 1999. It was created by the slow process we know as standards committees. Yes, you can remember it's pronounced SMILE, like the smile. Now, in the meantime, nothing happened for 10 years. Like animation, nothing happened. Flash just ran around rampant, and everyone was like, cool, bro, you do that. Smile just rolled around as well, not as implemented across the board. But then, over in the land of Applelandia, there was a twinkling in Steve Jobs' eye, and the Safari team was like, oh man, we gotta make websites look as good in the mobile browser as the apps do. We gotta add some animations in there, and we can't use Flash. Let's make some specs. So they dropped these gifts onto the standards bodies with no standards process. They were just like, here's some ideas, just take them, goodbye. And that's why there is not a lot of similarities between how SMILE is written and how CSS Animations and Transitions were written. There's some fun things. We'll talk about them more when we talk about how awesome the naming conventions of the API are. I'm a stickler for naming conventions. So meantime, over in the Internet Explorer camp, things were getting hairy. Essentially, SMILE, Transitions, Animations, those were 3 different animation engines, and each one of them had to be implemented separately. So the Internet Explorer was like, we demand normalcy. We're gonna do the CSS transitions and animations, but before we get to SMILE, y'all gotta get your stuff together. We need one API that can describe all of their different behaviors so that they can be more reliable across different browsers, and also so that we can open up the browser's animations engine while letting JavaScript developers get in there and do what they might need to do in the future. Well, it was a really, really big API. It was very, very large. So several years later, after much drafting, spec authors are finally nailing down the edge cases of this API. It's called, very creatively, the Web Animations API. Unfortunately, in the meantime, SMILE has gone the way of the dodo. Sorry, SMILE. But the Web Animations API is still a big deal for browsers and for animation on the web. You can already see it work in browser animation dev tools, like this one here in Firefox. Also in Chrome, these tools, these timelines, see how we're moving the fishes in the background, but not the fishes in the foreground? We're scrubbing their timelines. Not possible without the Web Animations API. Pretty cool, right? Nice trick. I pull it out at cocktail parties. So, it's an awesome API. It's a big deal. It'll change how we do animation on the web. I wanted to get the word out, so I teamed up with MDN last year to document it. It was a pretty awesome effort, and the docs are pretty comprehensive. And I thought when I was working on them and I had to make all these demos, who better to help me tell this story than Alice? So I brought her back for Alice in Web Animations API land. So let's get started with some core concepts. The Web Animations API is based on 2 models. There's a timing model and there's an animation model, or I like to think of them as the when and the what, right? So the Web Animations API is time-based. Currently, all animations must have durations. It doesn't have to be this way, but this is level 1 of the spec. It only seeks to reproduce what CSS Animations and Transitions are currently doing with a JavaScript API. But in the future, there may be room for timeline-free animations, gesture-based animations. It's a lovely API. It's written to leave the doors open for these sorts of things. But for now, all timelines must have a duration. These durations help create little animation timelines. Okay, so example, take the Cheshire Cat's animation. The Cheshire Cat takes 8 seconds to go from being there to being not all there, right? So we get this timeline, and the computer can break it down all the way down to milliseconds and know what he's going to look like at any one of those milliseconds. Woot. This lets us do all kinds of things. In the spec itself, it says that time may be shifted forwards, backwards, it can be scaled, reversed, paused, repeated. We call this stateless. This kind of animation is what we call stateless. Now, how does stateless animation stack up against more familiar JavaScript-based request animation frame animations? Well, unlike request animation frame, which is limited by how often the page is repainted, there are a couple of benefits. It's frame rate independent. No matter what your frames per second are, things are going to Animations API's grouping specs. So, timelines, they have children called animations. Animation objects, they line up along a timeline like trains line up on tracks. They can be moved forward and backward. They always take up the same amount of space. So they do this by connecting, animation objects do this by connecting a single animation to a timeline and determines what the element, this cat, should look like at any given point. The cat state, from there to not all there, we call this a keyframe effect. Always, if you say take 8 seconds, it takes 8 seconds. It might drop a few frames, but it takes 8 seconds. Direction agnostic. You can play it forwards or backwards very easily. The computer knows what it's going to be at any given time, so it doesn't matter where you are. All ways are Queen's ways. Seekable, once again, because you know what that animation is going to look like at any given time, you can plunk down anywhere in that animation with no problem, no extra effort. And one of the greatest things, all these things mean, and this is a problem that has actually come up, people are doing a lot more with choreographed animations on the web these days as they try to, material design really help push people into thinking about how can we have things moving in different directions or changing at different rates, not just the page turned, but this came in from the side and this came up from the bottom. These are called choreographed animations. And choreographed animations have to lock step with each other. It doesn't work if you've got multiple processes with request animation frame running on them and they end slightly out of place. This is something I'm seeing people asking me more about in the web animations community. The web animations API locks everything down time-wise. If something's going to end in 8 seconds, it ends in 8 seconds. If something starts at 8 seconds, it starts at 8 seconds, regardless. Really useful when you're trying to do those choreographed animations. Okay. Tangent over. As you can tell, that was a tangent. I didn't put a slide in for it. So, timelines have a hierarchy and they inherit. Okay, take a look at this. This cat was created with the CSS Animations API. Notice how they're all running out of sync. These are very messy cats. Over on the right, this cat was created with the Web Animations API. What's happening here is each cat div that I'm adding, I'm copying the current time value from this cat up here and applying it to each of them. So they are all at the same place in this animation. That way they all are referencing the same place in the same timeline. This is really important for level 2 of the Web Animations API's grouping specs. So, timelines, they have children called animations. Animation objects, they line up along a timeline like trains line up on tracks. They can be moved forward and backward. They always take up the same amount of space. So they do this by connecting, animation objects do this by connecting a single animation to a timeline and determines what the element, this cat, should look like at any given point. The cat state, from there to not all there, we call this a keyframe effect. Okay, keyframes. We're getting into fun terminology here, so I'm going to take you on a little side trip to the land of traditional animation here. The term keyframe comes from traditional animation. In traditional animation, we have these things called keys or key poses, aka also known as keyframes, right? So in interaction development, they were lengthened, weirdly enough, to keyframe, from key to keyframe. And also, back in traditional animation, all the things between these two key poses, walking cat and sitting cat, these are called in-betweens, and you don't want that job. It's a dead-end job. Nobody wants to draw all the in-between frames. That stuff is outsourced to Korea. You want to be the key animator. But in interaction development, in-betweens was shortened to tweens in Flash. So when someone's talking about tweens, they're talking about what the difference between those two states looks like. Keep that in mind. So keyframe effect is sort of synonymous with tweens from Flash animation. All right, so we got a timeline. We got this busted metaphor here. You know what the thing should look like at any given time, but how do you make it go? The animation object plays a keyframe effect along a timeline the same way a DVD player would play a DVD. That's how I think of it. In fact, at one point in the spec, animation was called animation player. It's a little confusing. That may be my fault. I'm sorry. I don't know if anyone in this audience actually remembers DVD players. Is this going to be an okay metaphor for me to keep using? Well, you're going to see it a couple more times, so I can beat it into you. Now, with these two models combined, timing and animation, the Web Animations API runs all the animation engines in the browser currently, including dead ones. So here's how it does that. I'm assuming everyone here has a good grasp of CSS Animations and Transitions, yes? Anybody here like, no? I see you in the back, you're a little scared. I brought you something. I actually happen to have a CSS Animations and Transitions course, and you get 20% off with Bedankt. There you go. Okay, so I won't spend the rest of this trip talking about those. Let's move on. I'll show you how to write those using the Web Animations API. So we've got the animation player, and it takes this keyframe effect that tells it what the animation should look like. Like a DVD has all the information on it about what your video is going to be at any given time, but you have to put it into the player and hit play for the thing to actually run. Let's take a closer look at that keyframe effect. So the keyframe effect constructor, pretty badass constructor right here. In the API, the keyframe effect tells the animation what it should look like at its key points, like the beginning and the end, your point A and your point B, right? The animation model then interpolates or tweens the rest. This is how we see he's kind of half there in the middle. Sweet. Now here's the original Alice in Videoland done with CSS Transitions. You click the rabbit, he goes down. Nice. How are we doing that? We're putting a class on the rabbit. The rabbit has a transition value. Anytime his transform property changes, that change will be interpolated over 3 seconds, right? When you click on him or tap on him, he gets a class of interacted, and the transform value changes to translate Y 100%, pushes him all the way down. And here's what that looks like. Go over, you're going to click on it. He gets a class of interacted, he goes all the way down. When I first did this, it was like, that was amazing, magical. Actually, I didn't tell you this, but I made this one with the Web Animation API, and you couldn't even tell the difference, could you? It's magic. Let me show you the loopholes I jumped through to do that. So we start with a new keyframe effect, right? New keyframe effect. We're going to pass it, just pretend white rabbit is, document get element by ID white rabbit. And then we also pass it an array of key value pairs, transform with the translate Y 0% and the 100%. And we also pass it a little timing object, which says we want it to last 3,000 milliseconds, and we want it to fill forwards. Fill forwards is pretty cool. We'll talk about that in a moment. We're also going to store all of this inside a variable rabbit down keyframes. Remember, we're making a keyframe object. We're just trying to make that animation. So here's what happens if you don't set fill mode forwards. Forwards is very important because if you don't set it, the rabbit just jumps right back into his original position. So what just happened there? So just like with a DVD, with the animation player, if you play to the end of your DVD or your keyframe effect, it just goes right back to the start menu. It's not even back to the beginning. It just goes back to its unplayed state. Whatever animation was running there, it just goes back to being whatever it was before you put an animation on it. When you use the fill forwards command, what you're saying is, hey, all those changes I made, they're sticky. Hang on to them. That's very important. That's how transitions work as compared to animations. They always fill forwards. So we've got some other really fun options, which we know a lot about from their CSS counterparts. So duration. Duration is the same equivalent as transition animation duration, right? Delay, same as transition or animation delay, how long you want to wait before you start playing it after it's been kicked off. Fill, which correlates to animation-film-mode. Iterations, shortened for animation iteration count. You see how much shorter the verbiage is in here? I love it. Direction, whether you want it to go from 0% to 100%, state A to B or B to A, or some combination of both. And easing, oh my God, easing is my favorite one. Animation timing function should have been animation-easing from the beginning, and it should have defaulted to linear from the beginning instead of ease. I'm very passionate about this, you can tell. So this API totally gets everything right. All right, now here's the shiny new ones, right? These are important for sequencing end delay, milliseconds to delay after the end of an animation. So if you got a callback on that animation, it doesn't actually fire for, I don't know, 4 seconds or whatever. Iteration start, it fires when the iteration animation, doesn't fire. Iteration start is when the iteration should start. That one's trickier to explain. I'm going to move along for the sake of brevity. We also have things like composite, iteration composite, much too much to get into right now. But they're out there if you want to read about them. They're on MDN. It's very comprehensive. Now, we got our keyframe object. Let's talk about that animation object. We need that DVD player. It's time to play. So here's our keyframe object. Nice, tidy, adorable. And we're going to shove rabbit down keyframes inside this DVD player, the animation object. And we do that with this clever constructor. We take rabbit down keyframes, we wrap it in a new animation call. Important to note, you see this document-timeline here? You have to pass a timeline object to a new animation object because it needs to know what timeline am I running this on. The trick here is that currently there's only one timeline supported by all browsers, and that is the documents timeline, the timeline that starts the minute you open the page. One day there may be other timelines, ones that are linked to, say, your scroll, like how long the page is, or you could create multiple timelines and then group different animations on them and trigger them, et cetera, et cetera. But for now, MVP, we have a document timeline. So whenever I start one of these up, it's like document-timeline. So you make a new animation object, you give it the keyframe object, you tell it, just go to the default timeline, wrap it inside a lovely variable, so you can call methods on it. Woohoo, methods. We got pause, we got play, we got reverse, which just plays it backwards. And we got finish, which jumps it to the end and fires any things that are supposed to happen at the end of it. We got cancel, which just takes the dang thing off and doesn't fire anything. It's awesome, right? It's almost like you have your own DVD player remote control. All right, so how we use it? We're going to call play on the animation object. Wrap it down animation play, nice. We're going to wrap it inside this down he goes function. And we're going to attach that to the click event listener. And also, of course, touch start, etc. But we're not going to put those in here for funsies. And of course, when it's over, we're going to have that event listener removed from the white rabbit. Otherwise, people will be able to make that animation run every time they click the rabbit hole, which gets very annoying very fast. My husband was doing that for like 30 minutes one night, and I was like, stop that. So, ta-da! Isn't it great? Aren't you proud? You weren't actually supposed to clap. That was a lot of work for 2 lines of CSS. Remember, it took 2 lines of CSS to do this. So fortunately, there is a shortcut. You do not have to write each individual object because we got an animate method, which you can call on any animatable DOM element. Hurrah! So we take this lovely 2 lines of simple CSS right here, and we just, hang on a moment, actually wait. Oh, special edition report here. If you're a CSS Animations wonk, you may have noticed that the Web Animations API handled this transition sort of like it was a CSS animation. When I first started making CSS animation demos, it wasn't uncommon for me to just scope a plays once animation to a class change. I mean, these look very similar. Here we've just got this transition saying anytime the transform change, I want you to do this. But I was going the long way. I was describing keyframes, and I was calling this animation on them and stuff. This is very common. This is essentially what the Web Animations API is writing when you're creating this animation. And look, it's even got forwards. So essentially, a transition is just a keyframe animation that runs once and fills forwards. All right. So let's try doing some CSS animations. They've got some more complicated properties that we can use to recreate them. There are 2 animations happening on Alice here. There's a big animation happening in the back. No, you repeat. The big animation happening in the back, we're going to ignore it, but Alice herself is spinning, and she's also, very subtly, changing from red to black. It's hard to see on that screen, but it's happening. Just trust me. Her silhouette is changing colors. So this is the CSS animation behind it. We're just going to pay attention to her for now. Yeah, Alice tumbling. It runs infinitely. It takes 3 seconds to complete each iteration. It has a linear timing function, which means that it happens at a constant rate. If we used ease in or out, she'd look a little wonky. She'd be like spinning and then look like she was in a washing machine, which might be the effect you're going for, but not me. And these are the keyframes here. This is where the magic's happening. The 0%, we've got color. At black, transform, rotate 0. At 30%, her color changes to red. And then at 100%, here at the full 3 seconds, you've got the color turning to black and her rotation completing at full 360 degrees. All right, let's use that animate method. So animate method works like this. You grab your element, you call animate on it, you pass it a keyframes object, and you pass it some timing objects. All right, what's that look like? Well, here's the keyframes object. Notice it looks just like the keyframes. We just left out the 100%, the 30%, the 0%, et cetera. How are we telling the color change to red right here, where it should occur? Well, we're using this thing called offset. It doesn't take percentages, it takes decimals. So 0.3 is obviously 3%. You can't go over 1, by the way. If you didn't put offset here, this would just happen at 50%. It would happen halfway through instead of at 1 second. It would happen at 1.5 seconds. Offsets are just a way of declaring that percentage point. Otherwise, by default, everything is equally distributed across the duration of the animation. So let's see what that looks like here. Here's that timing object. Notice we've got 3,000 milliseconds. We're not using seconds. It only takes milliseconds, which is, I feel like adding seconds to the CSS spec was also a mistake because nobody uses them as milliseconds. My God, milliseconds are where everything is. It's so parsable. And iterations, we're using the keyword infinity, so it happens for evs. All right, let's put them together. It's magic. Watch, it's happening, and bam! We go out, we get Alice, we get Alice by her ID, we call the animate shortcut on her, pass her the tumbling keyframes object and the timing keyframes object, and let's see what that looks like. Amazing, exactly the same, exactly the same. So the wonders of the Web Animations API, they never cease to amaze. That was American humor. But Rachel, you may be thinking to yourself, surely you did not come here to show us the long way to do CSS animations, which we already rock at. Well, that's true, I didn't. Let's talk about some of the things that the animation object lets us do that CSS does not let us do. We've got some nice attributes that let us do decidedly more than CSS. Let's take a look at them. We've got onFinish. It's a promise. People love promises, am I right? You got promises. OnCancel, also a promise. I heard you like promises. Ready, promise. PlayState, which is read-only. You use methods to change it. We covered those methods, play, reverse, etc. But you can also query and be like, hey, animation, what you doing? And it can be like, I'm playing. Playback rate, we'll talk about you later. And effect, which effect is kind of like the this of animation. It points to the keyframe effect. So when you say, hey, animation, what you playing? It's like, I'm playing this DVD. I mean, keyframe effect. There are a couple of others too. We've got, let's see, current time, which these are fun. Current time, which tells you where the animation is on its timeline. We use that to sync all those cats earlier. Finished, which is a callback. I'm a callbacks lady. I know I'm old-fashioned, but that's just how I work. I'm a big fan of finished. There are a couple of others too. There's start time, there's ID, but we're going to play with just these two for now. So there's this famous scene in Alice in Wonderland where Alice is drinking and eating, and she's growing bigger and smaller. She's trying to fit through this door, but she can't do anything right. There's a key on the table, she drinks the potion, she becomes small enough to fit through the door, but dang it, she left the key on the table. She has to go, she has to eat something so that she can get big enough to get it, but then she's too big to fit. Oh my God, it goes back and forth. It's kind of tiresome, but I thought, man, that sounds like it would be fun to animate. That would be a fun little game, right? Very hard to do with CSS animations alone, but surely this is a job for the Web Animations API. This is kind of what I had in mind. Let's see what's happening. And all this code, by the way, is available on the code pens. Love you, CodePen. So yeah, you can see when you tap on the Drink Me bottle, the water goes down, she gets smaller. When you click and hold on the Eat Me muffin, she gets bigger, and just, back and forthing forever. So what's happening in here? What is happening is that this animation is actually got two keyframes. It's got one keyframe. Got small Alice, she's half of her original size, and then we've got this big Alice who is double the original size. And we're going to move her up and down across this timeline using the two edibles as controls. Hooray! It's like forwards and rewind buttons. All right, so what are we doing here? We're going to take this, we're going to go out, we're going to get Alice, we're going to call animate on her, and here's the keyframe object. We take her from half of her scale to twice her scale, and there's a timing options object in there. Then we have to immediately call pause, or else the animation will run immediately. That's the fun part of the animate method, is that it will just run immediately if you do not call pause on it. So I'm going to go ahead and add pause in here. Alice change dot pause. All right, she's going to be paused. But she's so small, she's back at that tiny scale. If we jump her to finish, this is her at the end here. So you can see that's her times 2. Nice. So what are we going to do here? We want to change her current time. We want to move that player so that she is in the middle of her time, her duration. So she'll be about 1. So we get her effect, we get its timing object, we get the duration in that timing object, which of course is the full length of her animation, so it jumps her to the end. We divide it by 2. Now she is halfway through her animation at the beginning, and she's paused. Great, right? The nice thing is, to change all of that, you don't have to have some master variable with her length of her duration, etc. You can just reference her timing from her object directly. So you can update everything with just one spot. Woot. Nice. Now, to tie the playback controls in, we have the timeline. We set the playhead to be in the middle. Now we need to control that playhead on that timeline. We're going to use the cake in the bottle to send the playhead forward and backward using forwards and backwards. All right, we know forwards. We just hit play. Let's talk about how to get backward. There's one way to do that. We can take this shrink Alice function, and in it we can say Alice's playback rate, change it to -1. That will run it backwards. You could change it to -2 and it would run backwards twice as fast. Really handy. And then you hit play. And we'll also throw in the drinking bottles animation in this function. And we're going to attach an event listener to the bottle on mouse down and on touch events to play the shrink Alice. Now, there's a special thing in here. Alice change reverse would actually do the exact same thing as changing the playback rate to -1 and hitting play. But at the time of this writing, there were some bugs with that, with the polyfill, so I did it the more complicated way. Let's take a look at that. So there, when we touch her, she immediately plays backwards. And if we use reverse, does the exact same thing. Boo! Nice. Notice that she just kind of goes immediately, like you just tap it and she goes. That wasn't the interaction I wanted. I wanted it so that you had to hold down, you have to hold her down, hold down the drinking bottle to make sure that it continued to play. So we will solve that problem. All you need to know is we do the same thing with the cake. We change the playback rate to 1, we hit play, we play the cake's animation, we attach it to the cake. Nice. And we'll make sure to make this handy function that's going to stop all these animations. It's a bit of a hammer. We take Alice change, her animation, her going bigger and smaller. We stop it. We stop the cake's animation. We stop the drinking animation. We add event listeners to both the bottle and the cake so that as soon as people mouse up on it, it hits stop playing animations. All the animations will stop. Kibosh. So we got animations, go forwards and backwards, but all good games have to have endings. It's like, what good is getting to the end of the animation and you can't do anything anymore? There's gotta be some treat there to make people interact with it. Well, in the story, Alice wants to get through this tiny little door. She eats the cake, she becomes huge, immediately starts crying herself to death, and creates this sea of tears that when she finally drinks from the bottle, she gets small, she finds herself swimming around in this sea of her own tears. It sounds like me on a Saturday night. Anyway, she meets this mouse and is totally racist to this mouse, but that's another story. So I made these little vignettes. It's like here she's trying to get through the door, but oh no, the key's up there. And then there's this one of her crying, and you got this puddle slowly getting bigger. Nice, all right. Now we need to hook them into the game. So one or the other shows up depending on how big she is when one of the animations end. You know, she's gonna run out of drinking potion eventually, or muffin, or she's just gonna get really big or really small, and something should happen. So how are we going to control that? Well, glad you asked, my friends. We have 3 timelines on this page that we can check at any given time, and we can use those finish callbacks on. So this is what this interaction is gonna look like. All right, eat that muffin. She's getting big. I'm gonna hold it down. She keeps getting bigger. And, oh, she's too big. No one is too big, Alice. I understand. I was very tall as a child. All right, and she gets super small, super tiny. Oh, yeah. And if she's somewhere in between, you just get a play again message because you don't get rewards for taking no chances. So here's how we're going to call that. First, we'll need to set the animations on finish callback. We call this end game animation on all of them. They all, on finish, they get a callback to this end game function, or if Alice reaches the end of her animation. Here's what happens inside end game. We have to figure out her height. When everything is over, how tall is she compared to the largest size she could be? So first we get her playhead. Where is she on her current time? Alice change current time. And we get her timeline. Alice change effect active duration. Okay, fine, active duration it is. That seems complicated. And we find her height out by dividing where her playhead is by the timeline. This is very unfancy. Please, JavaScript people, don't judge me. So I love CSS. JavaScript is like, yeah, all right, Alice's height. We're going to compare it. You see if she's smaller than 33% of her total timeline, or if she's, she's further than 66% of her way through her timeline. We're going to run these different vignettes inside those options, and we're going to wrap it all inside the end game function, which automatically stops playing Alice. It looks pretty cool, and that's how you do it. Bonus. Something else you can't do with animation, well, not easily, randomization. So here you see that each one of her individual tiers, they're falling at different rates. I didn't hard code those, that would be gross. So what's happening here is there's a little randomizing function, ba-bam, at the top there. And inside each of these tiers, we go through all the tiers and we call animate on each of them. And inside their delay and their durations, those are randomized numbers. Yes, this is why sometimes you would like to do animations inside JavaScript. Badassery. Now for something you can only do with the Web Animations API, and I am super excited about this because it opens up some potentials for people who are, everyone experiences time at a different rate. This is something a lot of people aren't really cognizant of, but as you get older, time seems to literally speed up around you. There are many theories about why this is, but it's true. People experience time at different rates. I know when I'm very sick, I feel like the world is moving super slowly around me. And when you're very good at using an interface, you might find animations to be a little slow for you. Wouldn't it be great if you could speed up or slow down animations across the web to fit your own personal preferences? Wow, with the Web Animations API, that's possible. So super excited about this because it does have some accessibility. It does have some harbingers of people experiencing the web the way they want to for accessibility purposes. So no CSS randomization required here. In the sequel to Alice in Wonderland, Alice Through the Looking Glass, there's another great scene where Alice meets the Red Queen, and she and the Red Queen, they're running to stay in one place. And there's this thing where the Red Queen is like, oh my gosh, we have to run to stay in one place here, and we have to run twice as fast just to get anywhere. This quote is used all the time to talk about Wall Street, to talk about science, but it's a great game to play in your head, to think about what that would look like to run in a world where you have to run in one place to keep up. So Alice tires easily. She's a little girl. There's a decay on their running. You have to click on them to goad them onward. The Red Queen is just shouting at her this entire time, run faster, run faster. So you have to go over and click to speed her up. But the decay will set in immediately afterward. What's happening in here? Well, we go get the Red Queen and Alice. Red Queen and Alice is out there. Don't even ask me what I'm doing to animate them with this sprite sheet. It's pretty cool. You can inspect the code if you want to know more. We set the playback rate to 1. I mean, it's 1 by default, but I'm just pointing to it here. This is where playback rate lives, inside that beautiful timing object. Now let's make some fun stuff happen. We're going to set an interval. We want to tucker Alice out. So we're going to, every 3 seconds, we're going to multiply that playback rate by 0.9. It's going to get 10% slower every 3 seconds. And we're going to wrap that inside just because it will get really slow and wonky very fast if you leave this running in a background tab. We're going to make sure she never ducks below a 0.4 playback rate. And now we are going to do the exact opposite to make her go faster. We're going to multiply her playback rate by 1.1. So it gets 10% faster every time you click it or you touch it. Huzzah. That was pretty cool. But what if we could control several playback rates at the same time? Well, you absolutely can. I thought, I would love to show what happens in a world where you have to run to stay in place. It would suggest that as you slow down, the world would start speeding ahead of you, right? Okay, well, and then, so each one of these animations is now moving forward. And as you click, 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 get her to go twice as fast, suddenly they start moving backwards and they start making progress. Ta-da! All of their playback rates are now hooked up together. You will never use this in a regular website. That's okay. Demos are for fun. So what's next? Well, the good news is you can start learning and using the Web Animations API. I recommend that you do so personally. I feel like the Web Animations API is sort of, how do I put it? It lets you do a lot of things that typically people use an animation library like GreenSock to do for things that are not too complicated to do with the Web Animations API. So might be in 5 years, this is kind of like vanilla JS of animations, and libraries are sort of like the jQuery of animations. Fortunately, we have a polyfill. There's a polyfill that all these demos use. It's a little quirky, but they're really responsive to people who are filing bugs. It's maintained by good folks over at Google. Features are rolling out in Firefox and Chrome all the dang time. Edge has moved the Web Animations API into the backlog of awesome things to implement. And WebKit has animation objects showing up in their developer previews for both iOS and desktop. So we're seeing some pretty decent saturation across the board here. For full support coverage, I don't recommend going to caniuse.com. I recommend that you actually go to status.microsoftedge.com because it's a huge API, and CanIUse just does not get into which browsers are supporting which objects and which attributes. And this page does a really good job of it. I know you don't see Edge on that list, so if this API matters to you, you can totally vote it up at uservoice.microsoft.edge, and any other APIs you desperately would love to use. Give them your votes. You got a lot to spend. Also, let me know if you have a desperate crying need for the Web Animations API. I would love to hear your use case. The other idea is that animation libraries could build on top of the Web Animations API for improved performance. Because it lets you tap directly into the browser's animation engine, it allows the browser to make decisions about whether an animation should be run on a separate thread or not. It offloads a lot of performance legwork to, well, browser engineers, which is good for us developers. It also gives us a lovely format to export to for other tools to interface with. I'm really excited about the kinds of tools that are coming up for editing and animations on the web. I look forward to seeing Web Animation API JSON in there someday. More implementation means even more awesome tools. I want to give a shout out here to Chrome for their animation tools, which you can see down here as well. And of course, Level 2 introduces some features that we've been missing since the days of Flash, including grouping and sequencing. They will change everything. I talked about choreographed animations. This is required for that. Dan C. Wilson has written about this. They're currently not in Level 1 spec, but if you want to know how these would work, you should check out that article. So all animation is time and change, and that's what this API describes. And in doing so, it makes way for future animation specs, the future of animation online. Whew. All right, I want to give a shout out to some awesome people who were a part of this. Alex Miller helped me with some of these animations when I had pneumonia. He was my in-betweener and did a couple of the props and backgrounds. Thanks, Alex. Couldn't have made such awesome demos without you. Opal Essence, she's an editor at a comics publishing company. She did the logo. She does great lettering. I love her to bits. Chris Mills over at Mozilla held my hand during the documentation process at MDN. Couldn't do it without you, Chris. And Brian Bertels, who has been doing most of the authoring on the spec, took the time and patiently explained to me the finer details of how this works so that I could impart that information to you here today. They're all wonderful people. I'm so glad that they were there for me. So you're thinking, Rachel, I want to know even more about this. Where do I access this information? I guess I'll have to get some slides or something from you later. Guess what? There's the URL. Go to rachelnabors.com/WAAPI. You'll find all these resources, links to the documentation, and more. You can also sign up at webanimationweekly.com to get the latest coverage on all animation things on the web. We try to cover the spec there, too. If you want to discuss all good animation things, we've got a lovely Slack channel at animationnetwork.com. And of course, you can get your lovely goodies, and there's a special secret announcement on that page at rachelnabors.com/Amsterdam, which I won't go into right now because it's not 100% about the Web Animations API, but you know, it's awesome, so awesome. So with that, Alice and I would like to thank you for having us. You've been awesome.
Care to join me here? That was a lot of info. Very nice.
I hope the pretty pictures helped.
There was a lot of feedback on Twitter, so you have some reading to do after this, and lots of questions as well. Unfortunately, we won't be able to handle all of them for now. But one that I was particularly interested in relates to polyfills, because you mentioned that browser support is not quite there yet, and there's still new features being worked on. So is there a polyfill available for this functionality?
There absolutely is. It's linked to at rachelnabors.com/WAAPI, and it's maintained by the Chrome team. They're pretty good about keeping it up to date, and it does work pretty darn well.
Cool. There were also some questions about GreenSock. Are you familiar with this library at all?
I confess, I'm an animation hipster. I do all my animations with CSS or the Web Animations API. But I am familiar with it a bit. What sort of questions did you get?
Well, one person was specifically interested in using this API with SVG, which is apparently a very big use case for GreenSock.
That's right. GreenSock, as an animation library, one of its most popular use cases is that it sort of normalizes weird SVG behavior across browsers when it comes to animations, and animates some properties that in some browsers aren't animatable at all, like border offset. Yeah.
Wow.
So if you're doing SVG animation, you might look at GreenSock. I find most SVG animations can be done with CSS these days, though, so don't completely discount it.
Okay. And which feature are you most excited about that will still be added to the standard?
Oh my gosh. I'm excited about all of them, but I think my favorite is playback rate, just because being able to control the playbacks across like an entire website is so awesome. I love the idea of a future where banking websites will let people set their preferences to whatever they want for how long the animations should take, or make it just like make them all take no time at all, so you can have that jump cut interface. Because there are still some people who prefer an interface that just immediately changes under their fingertips. I'm not one of those people, but some people out there are hardcore old school.
Right. I guess it depends on what you're doing. For example, like a banking website, as you mentioned, you probably don't really need the animations there.
Depends.
You just want to get your work done.
Do they have a touch use case?
Oh, okay, yeah. There you go. That's, yeah. I guess it all depends, as usual, in web development, right?
Yeah, you see animation showing up a lot in scenarios where people are using touch to interface with the website, because fingers are not very precise tools for input, and animation giving you feedback as to what was touched and what is triggering this other thing to happen is really good for user experience. I'm not saying just go animate all the things. I'm saying watch people using your site on an iPad or on an Android tablet. Is there a point where they look confused? Could you perhaps throw some animation to show them that, yes, they did in fact, tap this menu item with their thumb when they weren't looking? It can really help clarify those interactions for people. Touch really brought about the need for better animation on the web. As I see people implementing more animations, I'm also seeing traffic increasing from touch-based devices.
Right. Okay, Rachel, thank you so much for your excellent talk.
Thank you for
having me. Give her a warm hand, please.